So for those who have been very familiar with the development of Quilibrium, you'll know that the purpose of Quilibrium beyond the mission is to, like, our big, hairy, audacious goal is to essentially replace Amazon Web Services. And so part of that has been having to build out services that are compatible with AWS's offerings. And the way that we're targeting our initial offering set of services that we're compatible with is primarily Amazon S3 and Amazon Key Management Service. The reason we target those two is because they are very low-hanging fruit. They're very expensive to use on Amazon. They're very easy to fit into the Quilibrium network as native offerings. And so by consequence, it's one of the easiest go-to-market strategies and has the highest amount of potential immediate growth for our customer base. So I'll go ahead and go through demoing that, and if this ends up being super fast, then this ends up being super fast. If it doesn't, then we'll just take it as it goes. So I'm going to go ahead and hit this button. Hopefully it actually works. Like I said, Streamlabs has been super wonky. Cool, it didn't work. Fun. All right, let me adjust the screen capture real quick, and hopefully I can get that working. There we go. Okay. So, all right, QConsole is now up. So the basic idea of QConsole is that, like I said, very similar to Amazon Web Services, but there is one unique component to it that we find really cool, is the ability to share assets between different accounts. Obviously, with Amazon Web Services, you can do like the IAM account linking, and you can basically delegate downwards to a series of accounts. But in terms of cross-account sharing, there's a very limited surface area, and for good reason. But the reason ultimately in Amazon's perspective is that the people who are using AWS traditionally are going to be in a silo. Like, they put their projects on Amazon Web Services, they launch them, they expose them, and then the world uses them, and that company, whatever they're doing with that, just continues to carry on, and that's it. In the decentralized world, there's a lot of places where you would actually want to have composability between assets. We aren't able to demo that composability through the QStorage templates today. I was hoping to get that completely sealed and ready to go. So unfortunately, we didn't get that in time, but I'll at least demonstrate what QStorage and QKMS are like, so people have a good understanding of how to use these. If you use the Amazon S3 APIs, the only difference between using QConsole's QStorage and QKMS is that the endpoints change. So if you're familiar with using an API, access key and access secret key like you normally would construct for an AWS account, works pretty much the same. The values are different, but works pretty much the same. You configure it the same, you just change the endpoint. And so what I have right here is the dev build of QConsole because I was tweaking stuff around the templates. Hopefully I stashed that and stashed everything around that in time, so this ends up being a full preview of how the S3 compatibility works. So we're going to go ahead and create a bucket. And in this example, I am literally going to demonstrate what it's like to deploy a website. So the way this works is you create a bucket, you name it whatever you want. It follows the same naming conventions and rules as Amazon Web Services. And we have a nice drag and drop interface for you to put your assets into if you want to go about it that way. I've got a window pulled up here. Let me drag it up here so you can see. It's literally just a drag and drop process. So like any web page that you're going to be bringing over, you just drag and drop and it uploads, and it's relatively quick. When you have it in the public bucket mode, which is what we're doing by default, it's a pretty easy thing to do. Like, you just literally drag and drop your assets over. I'm going to keep dragging stuff over, and then I'm going to drag the rest of this over as well. And then finally, what was the last thing I uploaded? Okay, cool. Then we're going to drag the rest of this. For those who have not seen the innards of the Quilibrium website, we've got a very simple and straightforward deployment process. It's a static page. But the cool thing about this is now that QConsole is available and the QStorage API is available, how we've been currently hosting it has been basically through GitHub Pages. We can actually now move over and self-host on Quilibrium itself. So basically the files, like when you have a public bucket, it's very straightforward. You just literally pointed at the given endpoint bucket name, and then you access that index path. Now, everything around this asset is based on like a relative path of it being at the root. So it doesn't actually load anything when we have this here because it doesn't know where to find it. You'll see a bunch of 404s, and you can see that the reason that there's 404s, if I pull this over a bit so my face isn't over it, you can see that it's trying to get it from the like path here. So what we do is the same thing you do with S3 APIs. When you create a bucket and you want to make it a website bucket, you can actually link it to a domain name. Like I said, some of this is not exposed at the moment because we've been tweaking some of the things to allow the template sharing feature. So unfortunately, I won't be able to show that, but the basic process is you set your DNS records up accordingly so that the CNAME is pointing to the bucket domain name. So very similar to S3, when you have like the raw bucket endpoint, you either do /bucket name, or you can do the domain name route where it's the subdomain dot in the ultimate case of where the QConsole APIs, etc. live, it'll be essentially bucket name dot qstorage dot quilibrium.com. And that's basically it. It's a very simple management interface. Like I said, we're going to be adding features continuously throughout, but as of right now, the API itself is actually 100% compatible with the Amazon S3 APIs. So if you just use the existing AWS tooling, you can do whatever type of configuration you want. It supports the ability to tag items, be able to do all sorts of esoteric configurations. If you want to have like a bunch of different policies that live at the bucket or live at the object level. If you want to apply the, this is probably more important for enterprise style customers, but if you want to enforce the object lock and legal hold policies that exist for S3, you can do that too. We support it outright. It's literally 100% compatible. We also support S3 Select. That's probably going to be the weirdest one that we have because it's a little bit complicated and there may be some edge cases there. So if somebody wants to test out the S3 Select APIs, by all means, we're very open to getting good feedback on that. And next up is QKMS. So QKMS, for those unfamiliar with Amazon's key management service, it allows you to create different key types, either for the purpose of encryption and decryption, signature verification, or producing machine authentication codes. Right now, I'm going to demonstrate a simple encryption case. We're going to use symmetric default, and that's going to use AES in order to encrypt data. So I'm going to say test AES key. And again, like always, you can provide tags in the same way that you do with AWS. And then when you create the key, you'll be able to go to it. And then you'll see the rotation history, which applies to symmetric keys. I think right now there's a bug where it shows up the rotation history on keys that can't be rotated. If that's true, we'll fix that. In the meantime, you put in plain text data. We're going to have a switcher, so you can do plain text or hex if you want to use this interface. But you'll be able to encrypt your data using that or using the APIs directly, and you end up with an output ciphertext. And we very simply provide that ciphertext immediately in a test decryption mode so you can decrypt that text, and you'll get, of course, hello world. And if you have something that is not correct, that is not decryptable, it will fail to decrypt, and you will essentially end up with no change. So that's basically it. You can schedule deletion. For those familiar, the deletion process, like you have a pending deletion, it'll show you the scheduled deletion time, and at that time it will actually delete the key material, or at least the key material that is the hash stored on the network itself. And of course you can cancel it and then re-enable it, and you can do any of those operations at any time. You can also rotate the key, so if you need to do key rotation, rotation is supported. The last thing I'm going to show is going to be actually a lot more relevant for people in the crypto sphere, which would be handling elliptic curve keys. So we're going to have a sample ECC key, and we'll go ahead and create that and pop into the view for that. For those unfamiliar with AWS KMS, one thing that is very important to understand is that the output data that comes from the APIs, specifically the AWS APIs, is in the format that is called DER. It is essentially the distinguished encoding representation. And what that means is it has a lot more bytes packed around the actual data that most people would care about. So in other words, if you are typically a wallet developer, like let's say you're building a crypto wallet, your familiarity with keys is almost always in the raw format, sometimes with a little bit of amendment around the V value of the ACDSA signature, but at the end of the day, it's in a raw format. So while the AWS compatible APIs are going to remain 100% compatible, so they will have DER encoding, the actual outputs include the raw format. So if you want to utilize the raw format for like interacting with crypto protocols, you can actually just get that directly. So we do offer both the raw output and the DER encoded output. And keep in mind, this is doing MPC, so the kind of like hand behind the wall that's doing some puppetry here is in this mode, I have it actually running the corresponding client-side MPC operation within QConsole itself. But as a configuration step, you actually can dictate where that lives and how that runs. So what we have here is a public key that we've generated. It's an elliptic curve key. We'll go ahead and drop in just some random, I guess not that random, but some hexadecimal, and then we'll go ahead and sign it. And it produces a output signature. Now note that this is a raw signature. So if you try to like copy the raw format, we actually need to put that, like switch this around. But if you copy the raw format and you try to verify it, it'll say signature verification failed. And that is specifically because the API is expecting it in the DER format. So if we go ahead and do that, then it verifies successfully. Similarly, if we have a modified message, it will fail all the same. So yeah, that's basically it. At the bottom, we do also have the raw KMS API calls. So if you would prefer to use the AWS CLI, you're more than free to do so. We have a bunch of samples for you to use. And we also have the corresponding Q client calls as well. So that's it. I mean, those two major services are like when you look at the nature of how a lot of these cloud companies began, and like, I mean, Amazon even, how they got started, like their first offerings, like S3 was one of the first. But when you look at some of the other competitors in the market, like Cloudflare, how they bootstrapped their like largest cloud customer like income source was actually through the use of an S3 compatible API in the form of what they call R2. And so this is like the super exciting bit that I have been building up towards for a long time. It ends up being a very simple demonstration because everything else is complexity that lies under the hood. The way that data is stored on QStorage uses a process called verifiable encryption. So in other words, if you don't have a public bucket where you don't have the key basically provided through the QStorage proxy, then this data is encrypted at rest and only accessible to those who hold the key material themselves. When you're using the browser interface, you are essentially creating a delegate key that allows you to do that through the browser, but at the same time, the encrypted data remains encrypted on the actual S3 API level. So if you're trying to use like the standard S3 APIs, you will hit an interesting issue if you're not using a QConsole created key to essentially dispatch all the proxying calls for you. Because otherwise you'll end up being able to, or not being able to decrypt the data that you're getting back. So that is something to keep in mind, but that's basically it at a high level. So we're very excited to open this up to more testers, and we look forward to seeing what cool things people create. I guess the last thing I want to mention is, while we're not showing it today, the way that templates essentially work is when you've created a bucket, like let's say that I've created a, what's a thing that won't be a spicy meatball in terms of things that I could say. Let's say that you create a virtual game system. Definitely not a console game system. Like, just a virtual game system that has a target architecture that is well known and people develop against it. And let's say that you have a template for running one of those virtualized game systems. If you create a bucket that contains that virtualizer, and you have a target name for the file type of the executable game, you can publish that as a template so that other people can clone that bucket, drop in the exact file that is specified as the pluggable item, and then when they expose their own bucket, they're exposing a fully contained virtualizer of that game. And so that's like a simple, easy example that comes to mind, but there's also some further examples in terms of like, what we're trying to do for the Farcaster community, for example, is like with the advent of Frames v2/mini apps, we're wanting to support the ability to make it very easy for you to convert a existing website into a frame. And so we have a template available that will let you essentially drop in your website as long as it has assumptions about like root path and stuff. And it will essentially wrap that and provide the relevant meta tags necessary to expose it as a frame. And we'll also like step you through the process of generating the signature needed to make it appear correctly in the mini apps section of the Farcaster app.